All right, guys, for our second example, this is a short answer question. It says find the first 4 non-zero terms and the general term of the Taylor series for a function centered at a equals 3, for which f of 3 equals 5, and the nth derivative of f at x equals 3 is given by the following function. And this is the function that we use only for n values that are greater than or equal to 1, because they are giving you the value of the function at 3. So we would not use this function to find f0 of 3, the 0th derivative. Right? We'd only start it at n is 1. So again, if we're using the definition of a Taylor series, we have to first evaluate the function at 3, which is given, which is 5. Then we're going to have to evaluate the first derivative at 3. So that would be replacing n with 1. 1 plus 1 would give us 2 factorial over 2 to the 1. And if we want to reduce that, that reduces down to be 1. Then to find the second derivative of f at 3, we're going to replace n with 2. So 2 plus 1 will give us 3 factorial over 2 to the 2, which is 4. So 3 factorial over 4, and that will reduce to 6 over 4, which is 3 halves. And then one more term, because it asks us to find the first 4 non-zero terms. It doesn't say the degree. Sometimes it might say degree, but it wants the first 4 non-zero terms. So now the third derivative at 3, we're going to replace n with 3. 3 plus 1 is 4 factorial over 2 to the 3 is 8. So 4 factorial over 8 is 24 divided by 8, which would reduce to be 3. So now that we have these 4 non-zero terms, we're going to replace our nth derivative with these values and write out our formula. So our first term is going to be 5 plus 1 over 1 factorial x minus 3 to the 1, because we're centered at 3. Then 3 halves over 2 factorial x minus 3 squared plus 3 over 3 factorial x minus 3 cubed. All right, so when we write out our terms, these are the terms that we're getting, and this is not simplified. We're just writing it out. And then to find the general term, don't forget that they did ask you to find this. That means that it is worth points. The general term of the Taylor series means we're just going to replace the nth derivative at 3 with this function. So n plus 1 factorial over 2 to the n. But then remember, we're also dividing by n factorial, because that's part of our Taylor definition, and then times x minus 3 to the n. And this would be our general term, but for only terms where n is greater than or equal to 1. Because this 5, we found because it was given, it's not the value you would get here if you replaced n with 0. And if we want to simplify this, we can simplify it a little bit. We can reduce. First term becomes just 5. Then the 1's cancel, we get just x minus 3. Here, this is going to reduce to 3/4 x minus 3 squared, plus this will reduce to be 1/2 x minus 3 cubed. And then our general term can even simplify, because n plus 1 factorial over n factorial, when we reduce that, we can write n plus 1 factorial as n plus 1 times n factorial. The n factorials cancel, and we get just the n plus 1 on top. 2 to the n stays on the bottom, and then the x minus 3 to the n. But remember, we're only using this for n greater than or equal to 1. Okay, so now if they wanted you to find interval of convergence, you can now use this rule to do that. All right. So for your homework problem, it's an AP question. I'm going to put up here. So you can access this, you can screenshot it if you want, but this is the open response question that we're going to do. So they're giving you a Taylor series, or they're telling you a function has a Taylor series about x equals 1 that converges over some interval of convergence. They give you the value of f of 1, the value of f prime of 1, and then they're giving you a rule to find the nth derivative at 1 for n values greater than or equal to 2, all right, because they gave you f of 1 and f prime of 1. Okay, so now you're going to use that to answer parts A, B, C, and D. And this kind of does a combination of topics that we've done so far. Okay, so this is going to be due on Friday. And I've also set up a Google Hangout later today for if you have questions on 8.7 or 8.8. Okay, so look at those assignments that we did. We had a book assignment, we had an AP question, we had the AP Classroom multiple choice questions from 8.8. So if you had specific questions on certain ones that didn't get answered by me through email, then you can join the Hangout and we can kind of go over questions for that. So I will see you then.